Welcome back to a new machine learning tutorial. In this video, we are going to talk about how we can do hyperparameter tuning using Optuna. We are going to talk about the logic behind the Optuna hyperparameter tuning, and we are going to visualize the hyperparameter tuning process. And at the end, we are going to train a new machine learning model with the parameters that we find from the Optuna. Let's start coding. I'm in VS Code interface right now. I'm going to be using this code editor in this tutorial, but you can use any code editor that you want, like Google Colab or PyCharm, completely up to you. And I'm going to start by closing this welcome page. I'm going to create something like optuna.ipmb will be working on Jupyter notebooks. I'm going to select kernel as 3.11.4, and now what I'm going to do is, firstly, I want to show you my Optuna version that I'm using, because sometimes libraries can change and codes working behind the codes can change, and what you see in this video when you try yourself maybe won't run. So for fixing it, you can install this version of Optuna and you can have your codes working 100%. Also, you can do it by pip install Optuna and this version like this. Also for the Mac side, you need to do pip 3. And now, after mentioning that, our topic is going to be hyperparameter tuning with Optuna. And let's talk about hyperparameter tuning firstly. Every machine learning model, most of them have parameters, and it can be like A, B, C, different for every model. Like every model takes different parameters, and we can tune them for having a better performance on the model. Like when you just import a model, let's say random forest classifier, and then train the model from scikit-learn, you defaultly train a base model, but it has parameters like 1, 2, 3. By the way, these are just for example. It can have both parameters like, let's say, text or numeric. I will say 12, 14 and 17, for example. And when we do hyperparameter tuning, we are basically finding the best working parameters and getting a better performance. Like, let's say we find A3, B8 and C17 works best on our evaluation metric. For example, if we are having a classification problem and we are training a, let's say, random forest classifier, then we are looking for accuracy. Let's say A3, B8 and C17 gives the best performance, and we find it by hyperparameter tuning and C17, and we set these parameters for our next uses of model. Like we export the model with these parameters, or we make predictions with these parameters, and the other stuff that we can do with machine learning models. Like if we are going to check the feature importances, of course we want to check the feature importances on a better model, and this is basically hyperparameter tuning, the process of finding the best parameters. And Optuna, in other hand, is a powerful library in Python for hyperparameter optimization, which uses efficient search algorithms and optimization techniques to find the best set of hyperparameters for a given model. So what I'm going to do is, firstly, I'm going to start with my imports. 100% we are going to import the Optuna. I already did it at the start, but I'm going to be redoing it. It's not important. I will say from scikit-learn.datasets, and I'm going to working with a make classification created dataset in this video, and I will import train test split, and then I'm going to say scikit-learn.ensemble. Let's import random forest classifier since we mentioned it at the start, and I will say scikit-learn metrics import accuracy score, and let's create our dataset. I will say x and y. I will say make classification, number of samples 1000, we are going to have like 1000 rows, number of features is going to be 20, and let's say number of informative is going to be 15, and let's say number of redundant is going to be, actually it's redundant, yes, now it's correct, is going to be 5, and I'm going to make this run. I will show you the x matrix we have right now and our y vector in other hand like this, and I'm going to make it run. Here we have a binary classification problem. We have the zeros and ones. Now I'm going to do a train test split. I will say X train, Y train. Actually, the order is X test, then Y train, and Y test. And then I will say train test split. Now I will say X, Y, and let's set the test size like 30%. So test size 0.3 means 30% of the data we created, the 1000 rows, which is 300, is going to be in the testing set and 700 is going to be in the training set. And we are going to train our models with the training set we have, and we are going to test them with the test set we set. Okay, now we are going to be coding on the Optuna side. We are going to define an objective function. So objective function is where you define the model and the hyperparameters you want to tune. Optuna will call this function multiple times with different hyperparameter values to find the best configuration. So we will say define objective and let's say trial, and I will say firstly we are going to define the hyperparameters to tune. Also we can name them, like let's say define hyperparameters to tune, and we will say number of estimators. So we are going to be using the parameters of the random forest, and if you are going to be trying on different models, you need to pass their parameters in here. And I will say trial that suggest integer, and now I will say number of estimators, and I will give 50 with 200. These numbers are going to be trying range, and then I'm going to say, let's say like max depth, and it's going to be trial that suggest integer. I will say max depth, and I'm going to give like 530. Now I will say minimum sample split, and I will say trial suggest integer again, and I will say minimum samples split. Let's give numbers like 2 to 20. So 2 to 20. And now I'm going to say create and train the model with the sampled hyperparameters. So we will say model, we are going to initialize it with random forest classifier, and now in here we are going to pass our parameters, like number of estimators will be number of estimators, max depth is going to be max depth, and also minimum sample split is going to be minimum sample split, like this. So next what we are going to do is we are going to fit our model X train. Again we are going to be picking training set, since we are going to train our model with the training set we have. Also let me quickly talk about the logic in here. So we are going to try these parameters in here. We are going to pick one for each, then we select the model like this with that parameters we took. I called it samples. Actually it's going to be sampled. So sampled hyperparameters means, let's say like we pick 50, we pick 30, and we pick 2 in here. These are going to be our sample for the hyperparameters, and then we train this model. Now we are going to make predictions with the model we train with the picked parameters. Let's say make predictions and evaluate the model, and we will say why predictions is going to be model.predict. We will use X test for the prediction side, and accuracy is going to be accuracy score Y test with Y predictions. Now I'm going to say return accuracy, and this is going to be our objective function. Now let's summarize it one more time. We defined an objective function, we defined the hyperparameters to tune. I'm going to work with 3: number of estimators, maximum depth, and minimum sample split. Then we initialize the model like this with the picked parameters from here. Then we fit the model on X train and Y train. We make predictions with the model we trained. Then we pick the accuracy from that. So now the next step is going to be creating and running the Optuna study. So what is Optuna study? Optuna study manages the optimization process, including exploring different hyperparameter configurations and tracking their performance. You need to create a study and then use it to optimize the objective function. So we will say study, and we will use Optuna, create study, and direction is going to be maximize. Then what we are going to do is, by the way, you can see that new study created in memory with the name, no name, and etc. So we will say study. Now we are going to say optimize. For optimizing the study with the objective function, we will pass the objective in here, the thing that we defined in here, and let's say number of trials are going to be 100. And as soon as I run this, we are going to see the different trials in here, like just in here, and when it finishes I will be re-recording and we will take a look at them. And it finished. Let's check one of them, like trial 0 finished with value 0.93. It's our score and parameters, number of estimators 84, max step 14, minimum samples split 4, best is trial with 0 value 0.93. So it tries like this and improves performance as soon as I go low, as you can see, and at the end I see 0.943334, and at that side we had a number of estimators of 191, max step of 21, and minimum samples of 12, and our value on that side is 0.92. And now we see that our last trial at this side. So in here best trial is 88, and let's go to the there for finding the score, and let me go to the 88, like it's right in here. The score is the highest one, and the parameters in that side is number of estimators 185, max step is 25, and minimum sample split 6, and our best is in here. Without it, it was 14. I'm not going to look at it, but our winner is 88. So let's analyze and use the results. So how we can reach to that parameters and this score is, without looking manually, we can just call like study the best parameters. For getting the best parameters that we see in here, let's check if they are same. 185, 25, and 6, yes. And also for getting that score, we can use study.best value. And now we can visualize this optimization process. Let's start with hyperparameter importance. So it's going to show us which hyperparameter is more important on the performance. So I will say Optuna, and we are going to use a built-in function to visualize the hyperparameter optimization. So I will say visualization, then I will say plot parameter importances, and I will pass study right now, and we are going to get our hyperparameter importances. And if you move your cursor at the right top, you can see that it's produced with Plotly. So great. So in here what we can see is the most important hyperparameter is max step, and the least important one in this tree is number of estimators. And you can see you can think like percentages, like sum of the 3 is going to be 100. Like, let me quickly show you. It's 0.61, 67, I'm sorry, plus 0.21 and 0.12 is going to be 1. And you can think like it affects in like 67%. This affects like 21%, and this affects like 12%. To sum up, this shows the hyperparameters with the highest importance have the most significant impact on the model's accuracy. This helps you understand which parameters you should focus on tuning in the future. And now let's visualize relationship between hyperparameters and objective value. It's useful to see how the value of each hyperparameter relates to the objective value, for example accuracy. This helps you understand how different ranges of hyperparameters affect the model's performance. So we will say Optuna visualization plot slice, and we will pass our study in here. Here it is. Here is our slice plot. So slice plot lets us to see how the objective value changes with different values of each hyperparameter. Like you can see, when max step is closer to 30, we see an increase in the objective value, just like in here. Like I can even zoom in here. This can help us identify trends, such as rather increasing a parameter like just like in max depth, consistently improves accuracy up to a point. Like, let me go zoom out and we can use it like this. And now let's visualize the hyperparameter search history. Tracking how the hyperparameter values change over time during the optimization process can provide insights into the search strategy. So we are going to say Optuna visualization.plot parallel coordinate, and we will pass the study in here. So we are going to have something like this. This displays the relationship between multiple hyperparameters and objective values simultaneously. It helps us to see how combinations of hyperparameters lead to different outcomes and identify potential interactions between them. And now let's visualize the optimization process. Reviewing the optimization history helps us to see how the objective value improved over time as Optuna explored different hyperparameter combinations. Like, let's say Optuna visualization plot optimization history, and I will pass study in here. So here is our optimization history, and we can see with trials how the objective value increases. And I'm going to zoom in a little bit for talking about it, not on that side. Let's zoom in here, and remember that we had a best value at 14, so from 14 to 88 we have the second best on there. It remained like same, and you can see that objective value decreased, increased with different trials, and from 14 to 18 it was the best for the 14, and after 88 we have the same best value and the leader is in here. So this plot shows how the best objective value found by the study has improved each trial. It's a good way to verify if the optimization process is converging and whether more trials might lead to future improvements. Now, okay, we have all of this. How we can use that? Let's train a new model with the best hyperparameters. So I'm going to call best parameters, and they are going to be study best parameters. And now I'm going to call best parameters. Here are them, the trial 88 values. And once you have identified the best hyperparameters from the study, you can use them to train a new model. This model should theoretically perform better since it's using optimized parameters. And how we are going to create that is, we can say random forest classifier, and with these symbols we can give best parameters like this. And I'm going to make this run, and I'm going to save it to something like best model, and it's going to be this. Now we can train this model. We just initialize that with the parameters we have, and I'm going to say best model.fit, and I will give xtrain with ytrain. So we are going to have our model with train best parameters performed, and we have the model that we wanted right now, the optimized version. Now let's say that we want to use this model in our estimations. Like, we can just say directly best model.predict, and then we can make predictions with passing the x in two-dimensional format. Also, what we can do is we can export this model. Like, how we can do that is we can use joblib. Like, I'm going to say import joblib, and I will say joblib dump, and I'm going to say like best model, and I'm going to say optimized model.pickle. I'm going to export it as a pickle file, and when I come to this explorer, you can see that we have this pickle file over here, and we can use it by, let's say we want to load it and use it. In joblib we can do it by, let's say loaded model is going to be joblib.load this time, and we are going to give this name in here. I'm directly going to copy from here, and after loading it in our apps, like, we are exporting this model because we want to take it out of the notebook and use it in our apps. And in our apps we can load it like this, and we can use loaded model.predict, and we can pass the x values in two-dimensional format. And in the side, this is how we can export the model. Okay, let's summarize what we did in this video, and then we can finish this video. So with starting, I showed you my Optuna version that I'm using and how we can install that version. Then I talked about the theory side of the hyperparameter tuning, like what's going on behind and what's the hyperparameter tuning. Then we make our imports. We import Optuna and a few stuff from scikit-learn, like make classification, train test split, random forest classifier, and accuracy score. Then we create our dataset with 1000 samples, which means 1000 x and y values. With 20 features, it's going to be our x matrix, and number of informative 15, number of redundant 5. Then we use train test split. Then we defined our objective function, and step by step we defined hyperparameters to tune. Then we created and trained the model with the sampled hyperparameters picked from here. Then we make predictions with the model we train and evaluate the model. Then we created a study and we start the optimization process, and you can see the trials. We logged them like this, and for the 100 trials we have these values, and we have a best performing one on the 88. Here we check these values, and I also showed you how we can see these values from calling study.bestParameters and study.best value. We saw that best performing number of estimators is 185, max step is 25, and minimum sample split is 6. Then we take the best value of that, and in here we plotted the hyperparameter importances, and we saw that maximum depth affects the accuracy maximum. Like the leading hyperparameter on the accuracy importance terms is the max step, and the least one is number of estimators. Next up, we have a slice plot. We checked our slice plot for seeing trends in hyperparameters. We create the coordinate plot, like how they are working together, the different combinations. Then we have the optimization history plot. I'm going to zoom out a little bit, and I'm going to move in here. We see that we have no improvement from 14th trial to 88, and then we finish with the 88 trial is best. We can see our optimization history in this way, and then I showed you how we can save this best parameters and our best parameters in here. Then we initialized a model with that parameters for having a better performance on the random forest classifier. Then we fitted it on the training data. Then I showed you how we can export this model in a pickle file format. Then I talked about how we can import it and use it in your apps. Using joblib again, we use joblib.load, and we can see that we can use that model's methods when we export it with joblib. So that's it. Thanks for watching. I have a machine learning tutorials playlist where I have 40 tutorials just like this one. You can check that playlist for more videos like this. I also share a new data science video on my channel every week. You can subscribe to my channel for more videos like this. Thanks for watching again. Let's get to the outro. Thanks for watching this machine learning tutorial on Optuna. I'm sharing new data science videos every week on my channel. You can subscribe to my channel for more videos like this. I have a playlist named Machine Learning Tutorials where I have more than 40 videos. You can check that playlist for more videos like this. I will be adding that playlist in the cards of this video.